Hi everyone. I'm just going to show you what we mean when we say please look at the video on Hegarty before starting the task, and also how you can use the Hegarty videos during the task as well. So this is what you should see, or you should see something similar to this when you click on one of your tasks. So this is task 156, which is collecting like terms 1. Now, what I want you to, I should just start actually by saying there are tasks set at the start of every lesson, and these tasks expire right the way into the next day. So what that means is that even if you don't necessarily do them all during the lesson, you could have a go at them on the evening. What I do is I sign them off and reset them on the next day, or choose a new combination of tasks depending on what people have done or what people have struggled with. I am also available during lessons, during lesson time, to answer any questions through Hegarty or on Teams or on email. Now, during lesson time means during lesson time. If you ask me a question outside of lesson time, I will still try to help you. I may also tell you that I will help you the next day or the next lesson, okay? Because there are lots and lots of students and lots of tasks to keep on top of, okay? It is not necessarily possible to help everyone outside of lesson time. So, imagine you have gone on to Teams and you have seen an instruction that says, good morning or good afternoon, everyone. Your tasks are set for you on Hegarty Maths. You've gone on to Hegarty and you've clicked on, and you can see that this is one of your tasks. So we're going to watch this video, and I'm going to pause it every now and again to kind of explain what it is I would be expecting you to be doing at home. Okay. So I'm not going to watch all 10 minutes. We'll just see how it goes.
Hi there, and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about collecting like terms, our first video. As always, let's link to what we already know. When we did SIRS and someone...
I'm just going to pause and say that if you are in year 7 or year 8, or potentially even year 9, then you haven't seen things that look like this before. You have seen square roots, and you know how to square root a square number. For example, the square root of 9 is 3. The square root of 64 is 8, for example. You haven't seen things that look like this. Let me show you something a little bit simpler, just to try to explain what's going on here. What he's doing is he's basically doing something like this, right? If I write 4 plus 4 plus 4 plus 4 plus 4 plus 4, he's about to say that, okay, yeah, of course we can add these up and we can get an answer, but we can also say we have 1, 2, 3, 4, 5, 6, lots of 4. We have 6, lots of 4. And then I can look at my times tables and do 6 times 4, which is, of course, 24. Now, the idea, of course, is we've really counted that there are 1, 2, 3, 4, 5, 6 4s, okay? If I did another example, for example, 5 plus 5 plus 5, then this one here is how many 5s are we adding up? There's 3 of them, and this will be 3 lots of 5, which is, of course, 15. Now, when we're doing algebra, we're not necessarily sure what the number is here. It could be standing for any number. So I'll give you one final example before proceeding with the Hegarty video. If I have a plus a plus a plus a, then the question is how else could I write this if I follow the same sort of logic as in this line here, or this line here, or this line here? Well, the logic would be I have 1, 2, 3, 4 A's. They're all being added up. So I have 4 lots of A. And because you've already done some work on algebra and you've been taught in a previous video that when you do a multiplication and you have a missing number, you don't write the times sign, so you would just write 4a. And that is the answer that you would write in Hegarty Maths. So just to point that one out, not to worry about the fact that it says square root of 2 plus square root of 2, etc. You could also have asked about that on Teams or on Hegarty or via email. Nobody has asked about that, so it must be okay.
Someone asked us to simplify or collect the following: root 2, add 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 root 2. We just said, do you remember? Well, that's the same as 6 lots of root 2.
So that's what
which
we
we
just
actually
said.
just dropped the multiply sign and said that's just 6 root 2, like this. 6 root 2. And from now on, remember, from previous videos I said we should really use the identical sign because they're just different ways of writing the same thing.
Don't worry about that either.
So,
again, you could have asked about that if you were unsure.
X add x add x add x add x add x. How would we write that? Yeah, it's exactly the same, guys. We would say it's identical to 6 lots of x.
Don't worry about the identity
we wouldn't write
symbol
6
with those
multiplied
three
by
lines,
x because we
you
don't
can
do
just
that in
use an
our
equal
algebra.
sign.
Alright, so that's the type of thing we're going to be doing here. This is called collecting up like terms. X is like another x, we're just collecting them up, mopping them up and telling us how many we've got. And that's basically what this video is. Just before we get going, let's just learn a little bit of terminology. Suppose you were considering the following: 2x add 5y add 7x. That is called an expression. Okay, so I'm just going to show you.
So what I would do if I was at home and I was a student, what I would do is I would write down on a piece of paper, potentially even in a notepad. That would be a pretty useful thing to have. I would write down the word expression. I would underline it, and I would write down this as an example. Okay, so an expression is exactly what we've already been looking at from last week. It's got some numbers in it, it's got some operations in it, and it's got some missing numbers as well that are replaced with letter symbols. Now, what we were doing last week was we were substituting values in. So, for example, if the expression was 2x add 3, so let's write this down so that you can see it. If the expression was 2x add 3, so here's another example of an expression. It's a BIDMAS problem waiting to happen. If I tell you x is 5, then this becomes 2 times 5, because 2x means 2 times whatever x is, plus 3, and this has become a BIDMAS problem. So all an expression is it is a BIDMAS problem that's waiting to happen, that's waiting to be told what numbers to substitute in. So if we actually evaluate this, which is another key word, if we evaluate this, we are going to work it out. We're going to do 2 times 5, which is 10, and then add 3, which is 13. Okay, so this here is an expression. There's lots of things that I could write down for expressions. 3a minus 5 is an expression. 12b cubed plus 5t is an expression. All of these look complicated, but when you put numbers in instead of letters, you can just work out the answer. That is what an expression is.
What each thing are. 2x add 5y add 7x is what's called an expression. Remember, it might have letters for algebra, it might have numbers, and it might have operations like add, subtract, multiply and divide. So what are our operations in this case? In this case it was add, but they could be add, subtract, multiply or divide. What's our variables? Let me highlight them and see if you know. The variables are the letters we use. They can vary in value. They're the unknowns. So our variables here are our letters, in this case our x and our y. What do you think the coefficients are? Well, let me highlight them and then you tell me. That's a coefficient, that's a coefficient, and that's a coefficient.
So again, what I would be doing is I would be using time during the lesson to be watching this video and to just be making these same notes that he is making.
The coefficients are the numbers in front of the variables. So they are the numbers in front of the variables. And that's important to know. Okay, so we've covered that. Now what do you think a term is? Again, I'm going to highlight a term for you. That's a term. That's a different term. And that's a different term again. So a term is just a part of the expression. It's the things that you're adding together or multiplying or subtracting or dividing. So in this case our terms are 2x, 5y and 7x. We've got 3 terms.
I would rather you think of terms as being things in an expression that are separated with pluses and minuses. So I'm actually going to ask you to make these notes yourself. Terms in an expression terms in an expression are separated by plus and minus symbols. So here's an example of an expression. I'll just write one down. We've got 5x minus 2y plus 3t minus 5xyt. So okay, it looks quite complicated. I know it does. I'm not asking you to do anything with it other than tell me how many terms are there. So I've got one here, one here, one here, and yes, this one here as well. Very long one in comparison. This expression has 4 terms.
Now here's where this is what this video is basically all about. What do you think a like term is? A like term is obviously a term. Which terms here are like? Well, 2x and 7x are what's called like terms because they're involving x's. Alright? And 5y is an unlike term to x terms because it doesn't have x's in it. So we would say, for example, a like term here is 2x and 7x. They can be collected up, and we could actually say we've got 9x if you think about it. Whereas 5y can't be collected up with anything. It's what's called an unlike term. It's unlike to the x's anyway. And they're the...
Yeah, so basically you've got 2 x's, you have 5 y's, and then you've got another 7 x's. Now, of course, x and y are really numbers. They are actually standing for numbers. We don't know what they are, but if x was 10, then I would have 2 10s and then also 7 10s. If x was 13, I'd have 2 13s and then also 7 13s. It doesn't matter what y is when we're just thinking about the x's, okay? What we're doing when we're saying that they are like terms is saying we can collect them together, and instead of saying I've got 2 of them and 7 of them, I can put them together and say that I have 9 of them. The 5 y's, we can't just group them together with the x's, because y might not have been 10 or might not have been 13. Y is allowed to be different to x.
Basic things we need to understand when doing this topic. So let's get ahead and just do some questions. We are going to be dealing with things like this, collecting the terms that are like, simplifying them, and writing down an answer. Alright, let's have a go. Collect the like terms here. Now,
right, I'm going to pause here. Now, I would strongly recommend spending, if this was you at home, continuing with this and watching the rest of it. However, when he begins the examples, I'm just going to try to make my video a bit shorter by showing you how you can still use this video while doing the task itself. So you would get to the point where he'd be starting to talk about some examples and things like that. And, you know, ideally you would finish the video. So we're going to pretend that you finished the video and you've clicked do quiz. Right, so we've got here question 1, and it says x plus x plus x plus x. Now, if I write something down which isn't going to be right, it's going to say, have you watched the video? You can get help. If I click get help, it will fast forward to a part of the video that helps with this type of question. So we're gonna pretend that I'm stuck and now I'm gonna watch the video.
I want to show you how to do this. I want you to always highlight your like terms. We've got an A, and I also, after you've highlighted the first one, I want you to highlight the next term and the operation in front of it. We've got an A, and we are adding it to another A, and this is identical to 2 lots of A. Nice and easy. I'm
just going to say, and no one's asked about this. No person has asked, sir, what does the 3 lines mean? Why does he keep using this symbol? No one's asked that. So either very few people have watched the video and haven't seen it, or it's not confusing anyone. But what I will tell you is for right now, don't worry about it. It's not going to really, it doesn't really matter that he's using this symbol. Not really, not in this context. So you can just write equals, okay? If I have A plus another A, you know, if I had 7 plus 7, that's 2 7s. If I had 33 plus 33, that's 2 33s. If I had 100 plus 100, I have 200. I have 2 lots of 100. If I have A plus A, then that is 2 lots of A, which in algebra is written 2A. This means 2 times whatever A is. So at this stage, I'm feeling confident of being able to answer this question. So I'm going to press this, and I think that this is 4x, because there is 1x plus another, that's 2x, plus another, that's 3x, plus another, that's 4x. So brilliant, I feel very pleased. I'm going to press next question. Now this is very similar to the one from before. Now as long as I can count, I should be okay. So this is y plus another y, that's 2y, plus another y, that's 3y, and then plus one more, that is 4y. Okay, so now I'm a little bit confused because I've not seen one like this. So I'm going to instantly press the Get Help button.
Okay, highlighting like term.
And what you'll notice is it has jumped in the video to the part of the video that helps with this type of question. So let's see what Mr. Hegarty has to say. And I'll also say at this point, I, your teacher, am sat at my computer throughout the whole lesson waiting to be asked for help. If you are stuck, if you are actually stuck, don't just tell me that you don't get it. Don't just tell me that it's too hard. You need to ask a bit more specific of a question. So you could take a screenshot of the question that you are stuck on and ask me about it on Teams. You could say, sir, I don't understand it when there's a number in front of the letter. At least that's more specific. That gives me something to help you with. Because if all you do is say that you just don't get the whole thing, I can't magically do anything more than tell you to watch the video on Hegarty Maths. I can't do more than that. It's not possible in the circumstances. I can attempt to write things down. I can make a video myself and try to explain it as well. And that is something that I have been doing. But to get help there and then, you need to ask a specific question. Because chances are you get some of it, right? You know that 2 add 1 add 4 is 7, for example. So you do get that part. If you watch the video, you would now see that I've got 2p plus 1p plus another 4p. So perhaps there are bits that you do get that can help you understand the harder questions.
So we've got 2p. We are going to add a p, which we can think of as 1p. It's helpful to do that. And we are going to add another 4p's. What have we got? Well, we've got 2p, add 1p is 3p, add 4p is equal to 7p's, or identical to 7p's.
Okay, so I'm going to pretend I'm still not feeling confident. I'm going to watch and do this second part.
Have a go yourself first. We have 5q. We are going to add a q, which we might put a 1 there just so we don't make a mistake. And after that, we are going to subtract this time. So remember to highlight the operation as well. 2.
Yes, that is really, really important. You need to be paying attention to where the takeaways are, because whatever comes directly after the takeaway is the thing that's being subtracted. Okay, so in this situation, I have 5q plus 1q, which is 6q. But then I'm going to be taking 2q's away, which is going to leave me with 4q.
What have we got? Well, it's identical to 5q add 1q is 6q. Take away 2q's is going to equal 4q's. And we're done.
Right, great. Well, I'm feeling like I could answer this question now. So 3r plus an r is 4r. Because there's 3 of them plus another one. Okay, let's have a look at this one. X plus x is 2x plus 3x is, so if I've got 2 of them and I'm adding another 3, that's 5 of them. Now, I'm not going to write 5 just by itself because I'm counting how many x's I've got, right? It's 5 x's that I have. Okay, so 6x take away 3x. So if I have 6, and this is where, you know, there are opportunities for me to try to explain it in different ways. So, okay, if I have 6 pencils, okay, 6 pencils, and I take away 3 pencils, I'm left with not just the number 3, I've got to be careful about what it is that I'm actually counting up. I'm left with 3 pencils. If I look at the question, I start with 6x. When I take away 3x, that is a like term and can be collected. It's 6x take away 3x leaves me with 3x. Now I should just say, and I'm conscious of the time on the video, I don't want it to go on too much longer, so I'm not going to do the whole thing. If I had something that looked like this versus this, these are different. These are different expressions. For a start, they look different. This one just says 3 and this one says 3x. Now they're different because if I put a value of x in and work the answer out, I'm going to get a different answer. For example, if I make x be 10, so if x is 10, this is 6 times 10 is 60, take away 3 is 57. But if I make x be 10 in this one, 6 times 10 is 60, 3 times 10 is 30, so this is no longer just 3, this is 30. 60 take away 30 is 30. And these are different. These expressions are not the same. This expression at the top is already fully simplified. The reason is that there are no like terms. This term here is an x term. This term here is just a number by itself. It's called a number term. And it will not be grouped together with the 6x because of BIDMAS. We actually work out what 6 times x is first and then take away 3 at the end. Whereas in this one, I actually can simplify this because they are both the same type of term. This is an x term, this is an x term, and taking it away, 6x take away 3x, leaves me with 3x. And 3x is just 3 times whatever the number is. So notice, if I do 3 times 10, I get 30. And it works. And it would work for any number that you chose. Right, let's see how much more of this we can do. I think I might finish the video there. I might skip a few questions and have a look at some of the harder ones. So skip. I will look at one like this, so we'll press get help because it looks a bit trickier.
So, highlighting...
And now what you'll see is in the video, he's skipping to a harder looking question. He skips to a harder looking question. So what I would encourage you to do is obviously watch that. You can press get help at any time of the video, of the task. You can do that at any point. You can also ask for help on Teams or on Hegarty itself or through email. I'm just going to answer this one just to show you what to do. And then I will finish the video because it is quite long at this point. So, what I would do is I would highlight the like terms. So I've got 7a and I'm plussing an a. So they're both what are called a terms. And then here I've got a positive 2b and I'm adding 3b to it. Okay, that's what's happening. So 7a plus a is 8a. And 2b plus 3b is 5b. Now these things are still being added up, and I think this is what is confusing some people. This whole thing is being added up. We're doing the 7a and the a and writing it as 8a. That part can be simplified. We're doing the 2b and the 3b and adding those up. That can be simplified. Oh, I've just realised it's I wasn't recording the bit I was talking about. I can't edit this video at this point, so we're just going to have to roll with it. What I did was I said we've got 7a and a. That's 8a. And the 2b and the 3b is 5b. And everything's being added up, so I'm still adding these bits up, right? This is 8 times whatever a is. This is 5 lots of whatever b is. And I'd be adding those up. And that would give me my answer. Apologies for doing all of this and not having it recording on the screen, but sorry about that. You could also, of course, watch Mr. Hegarty. He won't make as many mistakes as I do. But let's see if 8a plus 5b is the answer. Right, great. So hopefully this gives you a bit of confidence to try to make some more progress on Hegarty, okay? The videos are always there. You can always ask for help from me. You've got all lesson. You've got after the lesson as well to be doing this in your own time. And you can always get in touch with me via email and I will always do my best to help you, okay? That's certainly the case. Right, hopefully this was helpful. I know I've already said it quite a lot, but any problems, just get in touch. Just to say, I can see what people are doing and how much they've, actually attempted. And I would, you can ask for help at any stage, but please do make it clear that you have really tried to answer the questions as well. That helps me to understand where it is that you're going wrong, okay? Because if I can see a lot of attempted questions where you're making maybe the same type of mistake every time, that gives me an indication of where it is that you're going wrong. Right. See you later, guys. Bye bye.